And can a matter change its state? That means if a matter is solid, can it change to liquid or gas? Can it? Yes, it can. But it depends upon the type of matter and their temperature. For example, you can see liquid easily converts from ice to water. But for converting an iron into liquid state, you need a lot of heat. So we'll do it with the nicest thing, that's water. Let's take up the example of water. You already know what is water. Particles of matter are loosely, you can say moderately packed, moderately compressible, do not have fixed shape but have fixed volume. So when we take up ice, it's tightly packed. Then we put it into a container. Say this is our ice. Okay, my mind is not that good, don't mind. And let's say it's our burner. So if we suspend the thermometer, we will see that after 0 degree, its temperature is not increasing, but we are continuously supplying heat to the container. Then where is the heat going? Who is stealing our heat? Actually, in this case, no one is stealing the heat. The ice is the person stealing the heat. The ice is taking all the heat for itself to convert into water. So after 0 degrees Celsius, the thermometer would not show any increase in the temperature even on repeatedly supplying of heat until all the ice converts to water. Which means that if all the ice is not converted to water, its temperature would not increase. That would remain till 0 degrees Celsius. And we can define it in another way, that is latent heat of fusion. Now I said that I stole the heat we were supplying through the burner. Now we know that the ice was the steal or the thief who was stealing all the heat. But in science, the heat is said to be hidden somewhere in the container. So it is described as latent heat of fusion. Let's take up. Something I'll tell you interesting about this chapter is Celsius scale and Kelvin scale. Now Celsius scale is, it's 273. Let me confirm first from book, because I cannot tell you like that. Yes, it's exactly 27.3.16, and it's 0. It's starting. These are the starting points. 0 and this. So if you want to convert a Celsius scale to Kelvin scale, what would you do? The simplest thing you can do in that case is that if you're given that the temperature of a body is 0 degrees Celsius, so you will add 273, because we are taking 273 for our convenience and for easy calculation. Now we'll see that it would be 273 Kelvin. Now we were talking about converting of ice to water. Now let's talk about converting of water to vapors. That's a heating process. Let's go on. Let's say we have taken some water in the beaker. Oh, it's not a nice beaker. It's a beaker and we have taken some water. Okay. And we have put on it a burner. And we have suspended a thermometer. And we are continuously heating it. But where is the heat going? It's not showing heat above 100 degrees Celsius. The temperature is not rising. So, the heat is being stolen. But who is the thief this time? The thief this time is water, as the water is stealing all the heat from from our burner to make it to change its state from water to vapors. Okay, so in science we say that this heat that we are continuously supplying to the beaker is hidden somewhere inside the beaker, and we described it as latent heat of vaporization. Okay, which means that if you have steam at 100 degrees Celsius and water at 100 degrees Celsius, which would be more hot? I think steam, because steam would be more hot because it has the latent heat of vaporization, but water still has to get the latent heat of vaporization to convert into steam. So steam would be more hot and cause severe burns in your hands. So be careful while dealing with the water and steam. And some things take a little shortcut while doing all this. They do not convert from solid state to liquid state, but from solid state they directly convert into vaporous state. You must have seen your mothers putting naphthalene balls inside the blankets in the summers, so that you can take out those blankets in winters and they are not affected by the rodents and other insects. But when you open those blankets in winter, you see that those naphthalene balls are not there. And nor is something liquidy left on it. So we see that this naphthalene, instead of converting into liquid state, directly converted into gaseous state. This process is called sublimation. There are other examples of sublimation too. Okay, you must have seen your favorite band One Direction perform on the concert, and something smoke was going on the stage. You must have wondered what that smoke was about. That was about when they were putting some dry ice on the stage. The dry ice quickly converted into gas and was forming that smoke around the stage. The dried carbon dioxide. Is called dry ice. Now you must be wondering why it's called dry ice. Dry ice, it doesn't make sense, but it does in this case, because it's not converting into any liquid, it's just converting into gas. That means it's dry ice. So it's dried carbon dioxide. When you have to have, some fire is going on and you want to have a lot of carbon dioxide, then dried ice is a very good thing that can give a lot of carbon dioxide at a very small interval of time maybe. We have discussed about our two thieves, the ice and water, who took the energy from our burner to convert their states. Now let us look about the phenomenon of boiling. The boiling is actually the conversion of liquid to gaseous state. And boiling is a bulk phenomenon. You must have seen while you boil some water, all the particles come up like this, out. So that's a bulk phenomena. Boiling is a bulk phenomena. It's 100 degrees Celsius. It can happen only at 100 degrees Celsius, not below that. It needs a certain temperature. Okay, so we have first condition for boiling, second condition, and third is that how boiling happens. Actually, boiling happens when we supply heat to the particles of the water. They possess some extra energy so that they can break from their forces of attraction. Yeah, I just taught you that there are some forces of attraction between the particles of matter. So they have enough energy to break these forces of attraction and become free like gas. That's it. And it can happen only at 100 degrees Celsius. These are the two things that we can say for boiling. Now let's move on to the third thing. Now I would like to ask my fellow friends some questions. If you take some steam at 100 degrees Celsius and some water at 100 degrees Celsius, which would be more, hot and which would cause more burn to your body. So the answer I'm going to quote is steam. You must be wondering why the answer is steam. It can be water as well. In fact, it should be water as well for you because it looks like that. But no, the answer would be steam, because you see that water was the second thief while we were doing that, experiment for latent heat of, vaporization. It did not have the energy of latent heat of vaporization, but the steam possessed the energy of latent heat of vaporization. That's why it would be more hot. And be careful while handling the steam and water thing. Both can cause burns. Now